Hello grade 10s, this is your next short video on representing real numbers, number lines, set builder notation and interval notation. Okay, so let's get started. So representing real numbers, you've got different ways of doing it. The first one I've got here is set builder notation. So this is what set builder notation looks like. You always start and end with curly brackets. You've got your variable at the start, so for all x such that, so this colon stands for such that, and then you've got your restriction in the middle, so this x value, this variable can only be above -4 and below 3, okay? That's a boundary that you set. And then we say for all x, an element of one of the number systems. So now you can put there whole numbers, integers, natural numbers, real numbers, depending on what it is. Okay, so now it is integers, which means that it can be negative, positive, it can be 0. So now you have to also be able to represent this on a number line for us. So either representing it in the set builder notation or on a number line. So let's try and represent these with set builder notation. So here, just to quickly go over the signs. So this here at the top means less than. So whatever you write in front of it is less than. It opens up to the bigger one, something else. This one means bigger than, okay? And then if we are going to get to representing on a number line, not colored in circle, so an open circle means excluded, and then a full circle means included. Okay, and then once we get to something that less than and equal to, then we put a little strap at the bottom, and here if we were to and equal to, we also put the little strap at the bottom. So we start off by opening our curly bracket, we choose our variable x such that, and now we're putting our boundary, so greater than and including 3. So 3 is our lower boundary, and it's going to be greater than and equal, so x is greater than or equal to 3 for all x values which are elements of integers. So this Z symbol symbolizes integers. So that is how we will then write it. Okay, so the only things that change each time basically is your restriction and which of the number systems you chose. Okay, so integers less than 5, so we start the exact same, x such that, we've got that, x an element of, so now we have to just fill in the rest. It's integers, which means it's going to be z, and it's less than 5, so x less than 5, not including, just less than, as they stated. Okay, and then C is natural numbers less than 4. So once again, we start with x such that x is less than 4, not equal to, x an element of natural numbers, which is this n with a double stripe. Okay, you should know that as well. Now we move on. D says integers between -3 and -2 and 3, excluding -3, but including 3. So we start again, x such that, we've got our semicolon, and x an element of integers, which is the z, and then it's going to be, x is going to be between two things, but it's including the upper bound, excluding the lower bound. And you always write it from the lower bound to the upper bound. You cannot switch them around, then your question will be marked incorrect. So this next example says real numbers greater than or including 3. So once again, we start with our open curly bracket. We say x for all x such that, and our restriction greater than or including 3. So it's going to be greater than or including. 3 is at the bottom, x is greater than or including, and then we are going to say for all x an element of, and now we're talking about the real numbers, which are represented by this real number symbol. Okay, the next one says real numbers less than 7. So here we've got open curly bracket x such that, x has to be less than 7, not including, for all x that are elements of real numbers. Okay. The next one says real numbers between -5 and 4, excluding 5 but including 4. So we open our curly brackets. We've got for all x such that, and now x is going to be in between 2. We're going to have -5 on this side because we always start with the smallest one, end with the biggest one. It's excluding 5, -5, and including 4. And then we say for all x, an element of real number system. Okay. Okay, the next part is called interval notation. So it is where it's always applicable to real numbers. That's one thing that you should note. It's always applicable to real numbers. So it's not necessary to specify the symbol because we know it's for real numbers. Okay, so here on the right hand side, I'm just showing you that we use a round bracket for exclude and a square bracket when we talk about including something. So here we've got real numbers between -2 and 4, excluding -2 but including 4. So we always start with our variable x, an element of, and then we say excluding -2 will be round bracket, and we always start from the smaller one to the bigger bound like we did previously as well. And then 4 is included, which means that there we will use a square bracket. Moving on to the next example, it says real numbers between -4 and 7, including -4 but excluding 7. So we once again have x, an element of, a round e. -4 is included and 7 is excluded. So we use a round bracket. The next one says real numbers greater than or including 1. So here they don't give us any upper bound, which means that our upper bound, it goes all the way to infinity. So it includes 1 and it's greater than 1. So it goes all the way to positive infinity. And what's important to note is infinity and negative infinity is never included. So that is excluding infinity because it's not a real finite number which we can put our finger on. Okay, the next one says real numbers less than but not including -1. So once again, it's less than. It doesn't have a lower bound. It just says less than, which means that our lower bound is going to be negative infinity with an open bracket, and then -1 is also not included, which means it's also going to be a round bracket. Now for the second part of this video, I want to go back for the set builder notation and interval notation and go and represent this on a number line as well. So now we are going to draw our number line. We've got arrows at the end and we use our ruler to mark off the equal intervals. Okay, so here we're going to put 3 somewhere over here. We always mark it below the number line, and then we mark a few values going up and down on the number line. And because it's x bigger than or equal to 3, like we said here, included is a full circle. So 3 is going to be a full circle. It's bigger than or equal to, but it's elements of integers. Integers means we're going to use dots, okay? Because the next integer above 3 is going to be 4. The one above 4 is going to be 5. Integers is not the decimal places there in between. Therefore, it's going to go that way and carry on, okay? Or carry on this way, okay? So we use dots to represent integers. Then we've got another one. We're using integers. We make our number line, mark a few values, 5, 4, 6, and we go, it's going to be less than 5. So we're going to start, our first dot is going to start at 4. Here we don't use an open circle. We only use the open circle when we're working with real numbers. So we are going to make 2 dots. We see we're going, it's smaller than, and we're using dots because it's just integers. And 5 is not included. Very important. Next one says natural numbers less than 4. So here we're going to make our number line. What's important to remember here is natural numbers only start at 1. So we definitely have to show them that we know that. So we are going to go and mark off all the way to 5 using constant intervals. And it's less than 4. We're using dots because we're talking about natural numbers and not real numbers. So our first dot is going to be on 3. Then we go down to 2. Then we go down to 1. But that's where we have to stop because 0 is not a natural number. And -1 is also not a natural number. Natural numbers only start from 1 going up. It's integers starting from 1. Okay. And our restriction says it has to be less than 4. So that is all you draw for this one. The next one, D, says integers between -2 and 3, including -2, but excluding -2, but including 3. So here we have to at least mark off here from -3, -2, -1, 0, 1, 2, 3. And here we can include 3. Once again, we're working with integers, which means that we are going to use dots. And 2 is going to be included, 1 is going to be included, 0 is included, -1, but -2 is not included because it's just bigger than. So the first integer after -2 is -1. That's why that receives the first dot. Okay, now we're going up. Here we've got real numbers greater than or including 3. So now we're working with real numbers. When we work with real numbers, we use a line. We don't use dots. Okay, because everything is included, even the smallest, largest decimal values. So we're going to start here, mark a few values around 3. But it says bigger than or equal to 3. So we know 3 is going to be included and it's going to go bigger than 3. Okay, included. Remember, if it's included, we use the full circle. Okay, and then we've got real numbers less than 7. So we've got our number line here again. Here we've got 7, 6, 5, 4, going up a bit, 8, 9. And because we're working with real numbers, we're going to use a line. But 7 is excluded. So here is where our open circle comes in. The reason why we use an open circle is because the value that's just below 7, 6,9999999 going on, that value is included. Just the full whole number integer 7 is not included. Therefore, we make an open circle indicating that the one just below that is included and everything else below that. Okay. Then we move on, real numbers between -5 and 4, excluding -5, but including 4. So here we've got, going to mark a few values, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3. I'm going to run out of space, so I'm going to carry on here. Oh, okay, you should not do that. And then that is the the 4 is included, so that's a full circle, but the -5 is excluded, and then you connect those two because x is between -5 and 4. Okay, and then we carry on to interval notation. So how do we draw that? Remember, we only work with real numbers here, which means that all of these are going to have solid lines representing them and not dots. So we once again start marking off, at least including one bigger and one smaller than our boundary. 4 is included, which means it's a full circle. -2 is excluded, which means it's a empty circle, and you connect those two. Okay, remember the open circle indicated that it's excluding, and the square bracket indicates that it's including. Okay, then we've got B, once again starting with our number line. Sorry. -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Once again, running out of space here. So I'm going to make that negative 5. I'm going to do 6, 7, 8. And then from 7, 7's excluded, negative 4 is included, and then we draw a line between those, connecting them. Okay, and then we've got C saying real numbers greater than or including 1. Here we draw a number line again. We've got 0, 1, 2, and we know it's going to be including 1, going bigger because we're going to infinity, and we draw a little arrow at the end, and that's how we draw that one. And then the last one says numbers less than but not including negative 1. So once again, just drawing negative 2, negative 1, 0. Negative 1 is excluded, and it's everything below that line. And that is how we draw that. The last one you're supposed to be able to do is one that has a split interval. So read the following with me. Real numbers smaller than 1 and bigger than 3. Quickly read that and think, where would you place this on a number line? What does this look like? Okay, so writing this in set builder notation, we start the same way. Writing our curly bracket saying for all x such that, and now we bring our boundary in. X must be smaller than 1 and bigger than 3. So x must be smaller than 1 and x must be bigger than 3. Okay, look at that. We can't write this in the same way as we wrote boundaries where it was included, like here, because x there is between -5 and 4. Okay, here x is smaller than 1, and then it jumps, and then it's bigger than 3 again. And this is for x, element of real numbers, like we said. Okay, then for interval notation, the way you're going to write this is you're going to say x is an element of. Okay, I don't think I said included or excluded. Let's just say excluded for now. Okay, that's kind of how I did it for set builder. So we say, okay, it's going to be from negative infinity up to 1, and then it's going to jump and go from 3 to positive infinity. Okay, and what we put in the middle is this U, which means union. Okay, and then there it's set builder notation it is as well. It basically means it looks like a little bowl. I usually just think of it as like chucking everything in a bowl, so it's the one and the other, or the other. So it's not excluding one or the other. So drawing this on a number line from the interval notation is going to be it's going to be up to 1. And then we're going to keep on drawing our number line. And from 3, it's going to go up. And from 1, it's going to go down. Okay, so that is how it'll look. And the same if you draw it from here. If you draw your number line, you draw -1, 0, 1, 2, 3, 4. So from 3, it's excluding. It's going to go up, and from 1 it's excluding as well, and x is smaller than 1. So that is what we call a split interval, and here you see it side by side for set builder notation and interval notation.